Whenever we talk about simple harmonic motion, we keep on hearing this equation F is equal to minus kx, and everyone says this is the restoring force. So we will denote this by Fr. But students often ask, oh, wait, I was the one who pulled the spring in the first place. Why don't we talk about my force, the force that I applied, the applied force or the displacement force, instead of instead of talking about the spring's restoring force? And that's what exactly we will be clearing up today. So basically, we'll attempt to answer two questions. One is this distinction between applied force and restoring force, and why do we focus on the restoring force? And also we'll attempt to answer the question, why minus sign in the Hooke's law? So let's get going. Let's imagine we have a spring which is stationary and in its equilibrium position. Now, I apply a force with my hand and pull it to the right. That's the external force. I'll call it F external or F applied. I'm dragging the spring away from the equilibrium. But as soon as I pull, the spring pushes back with a restoring force in the opposite direction. So what happens is when I have pulled the spring, this F is acting in this direction, restoring force is set up. So what's happening over here? The applied force sets the system into motion and the restoring force is set up in the spring. At the new stretch position, these two forces are equal and opposite, and that's why the spring stays at rest while I hold it. So I'm holding it over here, I'm applying this FA, and it is in equilibrium position, not equilibrium to be precise, but it is stationary. So applied force is to the right and the restoring force is to the left. Now, what will happen if I release this object? That means FA is no more acting on this. So applied force disappears and the restoring force remains, and that force governs the motion. Now here's the key. The external force exists only as long as my hand is pulling it. So as long as my hand is pulling this, the applied force is there. The moment I let go, the force disappears. But the restoring force, that is still there. And it doesn't need me anymore. It's built into the spring's nature. So this force is already there in this spring. So in physics, we focus on the restoring force because that's the force which actually governs the spring's motion once you release it. And that's the force which is responsible for the oscillation of the springs. Let's take one more example. And that's the example of a ball in my hand. So what's happening over here? This ball is in my hand and let's say I apply a force and I apply force in the upward direction. This hand applies a force in the upward direction. And the ball leaves the hand of the thrower. In this case, it's me. And the hand provides the applied force. What happens next? Once the ball leaves my hand, so this ball is no more in contact with my hand, I have applied the force, it has left my hand, and in that situation, the only force acting on the ball is the gravity force, the gravitational force acting in the downward direction. And so the applied force is the runner, it starts off everything, it starts the motion. But physics studies the continuing force, the restoring force, or the gravitational force in this particular case. Because the motion of this ball in the air up and down depends only on the gravitational force or the restoring force in this particular case. And that is why the focus of our study will always be the restoring force. I hope this has helped you understand why we focus on restoring force. Now let us move on to the next question as to why the minus sign. So let us return to that equation F is equal to minus kx. The minus sign simply means the restoring force always acts opposite to the displacement. If I look at it from a math perspective, F is proportional to minus x. Here k is a constant, the spring constant, x is the displacement. And from this equation we can clearly see that the restoring force acts opposite to the displacement. So if this is the force of application, the restoring force is acting in this direction. This is the direction of displacement. This is the direction of restoring force. Without the minus sign, the force would push the object further away. Instead of restoring it, there would not be any oscillation. If this force, let us say the restoring force, was also acting in this direction, it would pull this object further away and oscillations would not be possible. That is why this restoring force is so very important. Right, so pull the spring right, force points to the left, and compress the spring, the force pushes outwards. That is why the negative sign. The minus sign encodes the direction, so the minus sign indicates this, the restoring force acts opposite to the displacement. So the next time you wonder why we don't talk about the displacement force, remember this: your external force is just temporary, it ends the moment you stop applying it. But the restoring force is the force which continues to act. It's always there. Conclusion: what conclusions do we draw from our discussions? First, applied force is the starter, restoring force is the runner. That's conclusion number 1. Physics focuses on the restoring force for all the reasons that we mentioned earlier in the video. Minus sign shows opposition to the displacement, and therefore we can say that the restoring force is the star of SHM. Thank you.